Stabilizing Global Temperature by Clive Maitlas. Email clivemaitlas@gmail.com if you notice any errors or have suggestions for improvement. Just send me an email, and the amendments will be put into the next edition. If you will read this book with an open mind, you may well see climate change from a perspective that is new to you. You will wonder why it has not been resolved decades ago. The scientific knowledge and the technical means are readily available. It is just that the political will is lacking. Available as a printed book and an e-book. Chapter, Executive Summary, Global Temperature is Rising. The temperature rise trend is undoubtedly at least partly due to human activity. Measures to reduce greenhouse gases, CO2, methane etc., are not likely to happen quickly. Not quickly enough to stabilize the temperature before tipping points are reached. The cost of decarbonizing the economy is extremely high. Net zero CO2 emissions is an important goal, but is unlikely to happen for several decades on an optimistic timescale. Even if net zero were reached, global temperature would continue to rise, due to the existing excess of greenhouse gases already stored in the atmosphere and dissolved in the oceans. Long before net zero is reached, we may reach various positive feedback tipping points. Beyond these points, temperature rise is likely to accelerate, with diminishing hope of controlling it. This is extremely serious. It is urgent. Net zero is far too slow to respond. Global temperature rise has been rapid since around 1970. With a further increase in slope from around 2022, provisional data. Sulfur and other aerosols have a significant cooling effect. This is well known, and has been known for over 2 centuries. Volcanic emissions were recognized as causing cooling since the eruption of Tambora in 1815. The year without a summer. Since around 1970 there has been a significant slowing of sulfur emissions from human activity, essentially flat from 1970 to 1990, then reducing. Meanwhile CO2 emissions continue to increase. If human-sourced sulfur emissions had continued from 1970 as a straight line increase, there would be almost zero increase in global temperatures today. Or indeed a slight reduction. High concentrations of sulfur in the air is harmful to humans and to trees. However, the concentration needed to stabilize global temperature is very low. It is at least 2 orders of magnitude lower than would be harmful to human health if applied in the stratosphere. Sulfur in the soil is a necessary nutrient for plant growth. Without it, plants are stunted and crop yields collapse. Since the desulfurization of coal-burning power stations, UK agricultural soil has become increasingly deficient in sulfur. Sulfur has to be added, or crop yields are impacted. Sulfur in the sea is a necessary nutrient for algae, phytoplankton, seaweed, kelp etc. These account for around a third of all CO2 uptake and half of all oxygen production. There has been a dramatic reduction of phytoplankton and kelp in recent decades, which appears to be correlated with the reduction in human emissions of atmospheric sulfur. Correlation does not imply causation. This is an area requiring further analysis. There may be multiple factors behind these reductions of marine photosynthesizing organisms. But sulfur is a necessary nutrient for them. We need to urgently know whether sulfur must be reintroduced into the marine environment. Other factors affect algae and phytoplankton. Some areas of ocean are depleted in iron. An experiment to add iron to these areas resulted in a significant increase in algae and phytoplankton, and consequent very significant increase in fish numbers. Despite being clearly beneficial, further experiments were banned by the Canadian government. Ocean fertilization with iron could be a highly effective means to draw down CO2, at relatively low expense. Ocean fertilization has the potential to sequester gigatons of CO2 per year. My suggestion is to use iron sulfate, thus addressing the iron deficiency and the sulfur deficiency simultaneously. It is commonly used as a lawn fertilizer. If there is a reduced drawdown of CO2 by marine organisms such as algae and phytoplankton, it is likely that the excess CO2 will remain in the atmosphere, hence contributing even more to global temperature rise. Plant growth is significantly enhanced by increased atmospheric CO2. Commercial greenhouses increased the CO2 up to 2000 ppm, which is about 5 times the current atmospheric concentration. And this 2000 ppm is about what it was when plants first evolved. Plants require less water as the CO2 increases, resulting in the greening of vast areas of semi-arid regions. If an efficient method of CO2 removal was implemented, and CO2 reduced to pre-industrial concentrations, there would be a sharp reduction in crop yields, and an associated food shortage crisis, and mass starvation on a vast scale never before experienced. Thus, CO2 reduction should only be done at a pace corresponding to the natural reduction of the human population, via humane means such as birth control, in order to avoid hardship and mass starvation. For the next few decades the human population is projected to continue growing, before leveling off. Global temperatures thus need to be stabilized, then reduced by around 1.5 degrees Celsius, without dramatically reducing atmospheric CO2. There seems to be only one method that is technically easy, economically viable, and immediately implementable: deliberately add sulfur and other cooling aerosols to the atmosphere. Above tropical oceans would have the greatest overall cooling effect. If the sulfur could be emitted far from humans and trees, high in the atmosphere and out above the oceans, then the benefit of its cooling could be obtained, whilst minimizing impact on human health. The concentration needed is very low anyway, much lower than you would notice by your sense of smell. Since the removal of sulfur from ship fuel since 2020, there has been a step increase in sea surface temperature. At low altitude, temperature is well over 100 times more sensitive to sulfur than to CO2. In the stratosphere, temperature is 5 or 6 orders of magnitude more sensitive. Before the removal of sulfur, ships' emissions were providing twice as much cooling as heating. The late Professor Stephen Salter investigated the use of fine salt mist dispensed from ships. This results in marine cloud brightening, due to cloud formation. Clouds cannot form without nucleation particles such as dust or salt. The air over oceans is very clean, and so clouds are less likely to form. The reflectivity of clouds is much higher than cloudless oceans. It could be done at relatively low cost. Professor Salter calculated that a fleet of drone vessels spraying salt mist to entirely halt global warming would cost less per year than one COP conference. He calculated that several years ago, and since then the number of attendees has shot up, in 2023 nearly 84,000. Could they not do COP via Zoom instead? Chapter: Recommendations achievable nearly immediately. We must urgently implement solar radiation management, SRM. One highly effective method is by deliberately adding sulfur to aviation fuel and to marine fuel. With preferably 2 grades of marine fuel, low sulfur for use in ports and near populated areas, and high added sulfur for use far from populated areas. The concentration of sulfur in the air reduces rapidly with increasing distance from ships. It would be straightforward to manage a vanishingly small impact on human health. Solar geoengineering, SRM, is a well-established concept. The sensitivity of global temperature to sulfur at high altitude, the stratosphere, is 5 or 6 orders of magnitude higher than to CO2. At low altitude, temperature is around 2 orders of magnitude more sensitive to sulfur than to CO2. Prior to banning sulfur from ship fuel in 2020, they were providing about twice as much cooling due to their sulfur emissions than heating due to their CO2 emissions. There may be some remaining arguments regarding the exact figures of temperature sensitivity to sulfur versus CO2, but such arguments cannot be an excuse for procrastination. We can refine the figures as we go. Also achievable in a very short timescale, weeks or at most a couple of months, convert surplus fighter jets to dispense sulfur dioxide at high altitude. The Royal Air Force is soon to retire some 30 Typhoon jets. These could be repurposed to carry around 7 tons of hydrogen sulfide to 60,000 plus foot when combusted in the jet pipe of the engines. This becomes sulfur dioxide. And the quantities required are astonishingly small. 1 sortie per day would cancel out the entire global warming contribution of the UK greenhouse gas emissions. Around 90 sorties per day would cancel the heating of entire world emissions of greenhouse gases. This is entirely achievable, and at an astonishingly small cost. Of course, it would be preferable if every major country were to fly 1 or 2 surplus military jets of comparable performance, and not concentrate all the sulfur over the UK alone. In context, there are around 90,000 commercial aircraft flights per day. Achievable within a few years' timescale, marine cloud brightening using saltwater mist. The equipment can be fitted to existing ships. And to fill in gaps of coverage in areas away from shipping routes, a fleet of drone boats can be deployed. A very fine mist of salt water is sprayed into the air. The droplets are carried by air currents to a few thousand feet altitude. The salt particles form nucleation points onto which larger drops of water condense to form a cloud. The air over oceans is typically very clean. The air may be moist enough to form clouds, but without nucleation points, clouds will not form. Clouds are far more reflective than a cloudless ocean, reflecting a significant proportion of solar radiation back into space. Whereas ocean water absorbs sunlight which then warms it up. The late Professor Stephen Salter calculated the annual cost to stabilize temperature globally by marine cloud brightening, MCB, is less than the cost of a COP conference. That was calculated several years ago, when the number of delegates was half their recent number. And yes, MCB would change rainfall patterns, but, except in a very few areas, there would be more rainfall in currently arid areas. Overall it is highly beneficial. The resulting change of albedo can be monitored by satellites in nearly real time, and so if problems were to arise, the spraying of salt mist could be halted, or moved to other locations. There will not be one single approach that is needed to stabilize global temperature, but multiple in combination. It is painfully obvious that CO2 emissions will not be stabilized in any realistic time frame, and may not be desirable to do so too rapidly anyway, without risking significant crop yield reduction and hence starvation on a previously unknown scale. We do urgently therefore need to deploy solar radiation management at large scale, and as quickly as possible. And do so before various irreversible tipping points are reached. Within a very short time frame, oil refineries can stop removing sulfur from aviation fuel, and also some grades of ship fuel, and can do so economically. This will buy us some time, as we develop equipment for marine cloud brightening via saltwater spraying, to be fitted to existing ships, and to drone boats. We do not need to give up hope. It is all eminently achievable.